Hello everybody, how you doing? Hope everybody's doing fine, I really do. And we're going to get into this video here in just one little second. Hope you like the new intro, and this is what we're going to use from now on. So much love, fasten your seatbelt, and let's get her going.
Radiofrequency/microwave radiation biological effects and safety standards, a review Scott M. Boland, June 1988. Abstract: the study of human exposure to radiofrequency/microwave radiation has been the subject of widespread investigation and analysis. It is known that electromagnetic radiation has a biological effect on human tissue. An attempt has been made by researchers to quantify the effects of radiation on the human body and to set guidelines for safe exposure levels. A review of the pertinent findings is presented along with the American National Standards Institute, ANSI, recommended safety standard, C95.1-1982, and the United States Air Force permissible exposure limit for RF/MW radiation, AFOSH standard 161-9. February 12, 1987. An overview of research that was conducted in the Soviet Union and Eastern Europe is also included in this report. Introduction: in 1956, the Department of Defense, DoD, directed the armed forces to investigate the biological effects of exposure to radiofrequency/microwave, RF/MW, radiation. The Army, Navy, and Air Force departments commissioned a tri-service program under the supervision of the Air Force to meet the DoD Directive 14-15. The Rome Air Development Center and the Air Research and Development Headquarters were ultimately given responsibility to manage the program. On July 15 to 16, 1957, the first of 4 tri-service conferences was held to discuss the effects of RF/MW radiation. These conferences were the first major effort put forth by the scientific community to explore the biological effects of exposure to RF/MW radiation. 14. Since then, researchers have discovered a number of biological dysfunctions that can occur in living organisms. Exposure of the human body to RF/MW radiation has many biological implications. The effects range from innocuous sensations of warmth to serious physiological damage to the eye. 1, 2, 5, 6, 8, 15. There is also evidence that RF/MW radiation can cause cancer. 81. The absorption of RF/MW radiated energy causes biological reactions to occur in the tissue of the human body. In order to determine safe exposure levels and to understand the effect of RF/MW radiation, it is necessary to know the absorption characteristics of the human tissue. The National Institute for Occupational Safety and Health, NIOSH, 8 has reported several physical properties that account for energy absorption in biological materials. Factors which govern energy absorption include: 1. Strength of the external N/M field, 2. Frequency of the RF/MW source, 3. The degree of hydration of dye tissue, and 4. The physical dimensions, geometry, and orientation of the absorbing body with respect to the radiation M field. 8. There is some disagreement among researchers in determining a specific measure for the dose of RF/MW radiation contracted by I1. Biological materials. The most commonly accepted measure is the specific absorption rate, SAR. The SAR is defined as the rate at which RF/MW radiated energy is imparted to the body, typically in units of watts per kilogram, W/kg, 41. The deposition of energy spec'd in terms of milliwatts per square centimeter, MW/cm2, over the irradiated surface is ALO widely accepted 9. Based on the known absorption rates and the inherent biological effects of RF/MW radiated energy, researchers have put forth a number of standards regarding safe exposure levels. In some instances, standards recommended by different examining authorities are in conflict. For example, the U.S. Air Force Standard 161-9, enacted February 12, 1987, allows for a permissible exposure level of 10 mW/cm2 for persons working in restricted areas and 5 mW/cm2 for persons working in unrestricted areas. 10. The ANSI guideline specifies a maximum safe exposure level of 5 mW/cm2 over the whole body area for anyone in contact with RF/MW radiation. 9. These differences reflect the way in which each examining authority has interpreted the available RF/MW radiation exposure data. 2. Biological effects. Exposure to RF/MW radiation is known to have a biological effect on animals and humans. Damage to major organs, disruption of important biological processes, and the potential risk of cancer represent the dangers of RF/MW radiation to living organisms. Pulsed radiation appears to have the greatest impact on biological materials. 8. The response of biological materials to the absorption of thermal energy is the most perceptible effect of exposure to RF/MW radiation. 7. The energy emitted from an RF/MW source is absorbed by the human tissue primarily as heat. In this case, the radiated energy is disposed in the molecules of the tissue. Dipole molecules of water and protein are stimulated and will vibrate as energy is absorbed throughout the irradiated tissue area. Ionic conduction will also occur in the same area where the radiation is incident. It is from these two natural processes that radiant energy is converted into heat. 11. The thermal effect of continuous wave, CW, and pulsed radiation is considered to be the same. 13. Non-thermal responses can be less noticeable and are often more difficult to explain than thermal effects. These responses are related to the disturbances in the tissue not caused by heating. Electromagnetic fields can interact with the bioelectrical functions of the irradiated human tissue. 8. Research conducted in the Soviet Union and Eastern Europe suggests that the human body may be more sensitive to the anthema effects of RF/MW radiation. 3. There are many reported biological effects to humans and animals that are exposed to RF/MW radiation. A review of the important findings is given in the following. A. Heating FFM on dye skin. Most RF/MW radiation penetrates only to the outer surface of the body. This is especially true for RF/MW frequencies greater than 3 GHz, where the likely depth of penetration is about 1 to 10 mm. 3. At frequencies above 10 GHz, the absorption of energy will occur mostly at the outer skin surface. Since the thermoreceptors of the body are contained primarily in this region, the perception of RF/MW radiation at these frequencies too may be similar to that of infrared. 1R, radiation. 3, 6. In 1937, J. Hardy and T. Oppel published an investigative paper on the thermal effects of IR radiation. Their findings were used by O. M. Gandhi and Abbas Riazi 6 to explain the thermal effect of RF/MW radiation on the human body. The reference for Hardy and Oppel can be found in 6. Figure 1 shows the results obtained from the 1937 report. As described by Gandhi and Riazi, the findings presented by Hardy and Oppel show that centiidens of warmth begin to occur when the whole body is irradiated at a CW power density of about 0.67 mW/cm2. Hardy and Oppel based their work on exposure to IR radiation. From other published reports, Gandhi and Riazi noted that there is a correlation between the radiating frequency of the incident RF/MW energy and the threshold for perspion. For example, on an exposed area of the forehead of 37 cnm, a perception of warmth was reported for incident power densities of 29.9 and 12.5 mW/cm2 from sources radiating at 3 and 10 GHz respectively. 6. Other observations made by Hardy and Oppel showed that when smaller body areas were irradiated, larger power densities were required to stimulate the thermal receptors in the skin. Gandhi and Riazi were able to confirm this result with reports from recent papers. They found that irradiation of an exposed body area of 40.6 cm2 to a power density of about 21.7 MW/cm2 yielded the same thermal perception as did the irradiation of a smaller body area of 9.6 square centimeters to a power density of about 55.9 MW/cm2. Hardy and Oppel reported that thermal sensations occurred within about 3 seconds after irradiation of the body tissue. More recent findings indicate a reaction time of closer to a second, 6. Gandhi and Riazi, 6 have also reported that the depth of penetration of RF/MW radiation has an impact on the power density threshold needed to stimulate the perception of warmth. As a comparison, IR radiation will not penetrate the outer body surface as deeply as RF/MW radiation emitted at a frequency of 2.45 GHz. Clinical observations have shown that irradiation of the ventral surface of the arm by an RF/MW source radiation at 2.45 GHz will cause a sensatki of warmth when the incident power density is about 26.7 MW/cm2. For incident IR radiation, a perception of warmth occurs at a power density of 1.7 MW/cm2. They estimated that at millimeter wavelengths the perception of warmth may occur at a power density level of about 8.7 MW/cm2. Exposure to higher levels of radiation can cause serious biological effects. Because of the physical dimensions and geometry of the human body, RF/MW radiated energy is non-uniformly deposited over the whole body surface. Some areas on the skin and outer body surface will absorb higher amounts of the radiated energy. These areas will be marked by hot spots of high temperatures, 7, 11, 16. Experiments conducted on laboratory animals have shown that skin burns typically occur in the areas of hot spots. The penetration of RF/MW radiation also causes skin burns to be relatively deep. 11. In experiments sponsored by the Tri-Service Commission, it was reported that RF/MW radiation burns over the NRB cages of dogs caused severe subcutaneous damage that did not visibly appear for weeks after the injury was sustained. 20. Burns can cause increased vascular permeability. This can lead to significant losses of body fluids and electrolytes. Serious burns can suffer fluid losses for a few days. Blood circulation can be altered in the affected area and other biological functions could be indirectly affected. 12. Beautifully body hyperthermia. 3. Thermal energy absorbed by the whole body can cause a rise in body temperature. When the human body is irradiated by an RF/MW source at an incident power density of 10 MW/cm2, there will be a rise in body temperature of about pC. The total thermal energy absorbed at this power density is about 58 watts. Typically, at rest the human basal metabolic nRT is about 80 watts and it is about 290 watts during periods of moderate activity. Exposure of the human body to low-power RF/MW radiation does not appear to impose any appreciable thermal hazard. These figures were reported by the U.S. Department of Health, Education, and Welfare. 3. Adverse biological effects can occur when the body is subjected to high doses of RF/MW radiation. 161. In this instance, large amounts of thermal energy can be absorbed by the body. A dramatic influx of energy can overburden thermoregulatory mechanisms. If excess heat cannot be exhausted, the core temperature of the body will rise to a dangerous level, resulting in hyperthermia. 12, 16. The biological response to excess heat buildup is the dilation of blood vessels at the surface of the skin and the evaporation of water through sweating. These are the primary mechanisms for heat dissipation. Hyperthermia can cause severe dehydration and the loss of electrolytes such as sodium chloride. Other harmful effects include fever, heat exhaustion, and heat fatigue. Heat stress is the most serious consequence of hyperthermia. Cardiac failure and heat stroke can result from heat stress. 12. It has also been noted that hyperthermia may cause injury to blood-brain barrier, BBB. 19. This barrier refers to the several biological materials that separate the essential elements of the central nervous system from the blood. 18. High cerebral temperatures exceeding 439 C may damage the BBB. The result can be a disruption of blood vessel continuity or integrity and degradation of the flow of blood and other body fluids in the brain. 191. See local hype/HERMDA. The non-uniform deposition of RF/MW radiated energy over the whole body surface causes the body to be heated unevenly. Local areas where temperatures rise above 41.60 C can experience damage to the tissue. 161. In these areas it is possible that harmful toxins could be released as a result of the high temperatures. Heating can cause cell membranes and blood capillaries to become more permeable. An increase in capillary permeability can lead to a loss of plasma proteins. The denaturation of proteins can also occur within cells. 111. 16. This can lead to changes in the physical properties and biological functions of proteins. 18. Denaturation of proteins can also cause polypeptide and histamine-like substances to become active. 11. 16. Histamines can stimulate gastric secretion, accelerate the heart rate, and cause the dilation of blood vessels resulting in lower blood pressure. 18. Areas of the body where blood circulation is poor or where thermal regulation is insufficient, are more susceptible to injury. 11. Carcinogenic effects. The carcinogenic effects of exposure to RF/MW radiation are not well known. It is difficult to clinically establish a link to cancer. The problem that researchers have in linking RF/MW radiation to cancer is that the disease itself is prevalent and can be caused by a variety of environmental factors. In fact, cancer is the second leading cause of death in the United States. There are, however, published reports that reveal some insights into the carcinogenic nature of RF/MW radiation. Non-thermal effects may provide important clues to the U1DR1 negative carcinogenic reactions in the human body. 8,32. Pathological reports. In 1962, S. Prosnitz and C. Susskind reported experimental results that showed an increase in cancer among test animals exposed to RF/MW radiation. In the experiment, 100 male Swiss albino mice were irradiated by a 10 GHz RF/MW source at an incident power density of about 100 MW/cm2. The mice were exposed for 4.5 minutes/day, 5 days/week for a total of 59 weeks. It was noted that irradiation caused the whole body temperature of the mice to rise about 3.3 Tc. Upon examination, it was found that 35% of the mice had developed cancer of the white blood cells. The disease was observed as monocytic or lymphatic leukosis or lymphatic or myeloid leukemia. Only 10% of a similar control group had developed cancer. 21. There have been a few allegations that RF/MW radiation has induced cancer in humans. 8,151. The NIOSH Technical Report 81 cites charges made in the early 1970s against Philco Ford and the Boeing Corporation that occupational exposure to RF/MW radiation caused cancer among employees. One incident was reported at each company. At Philco Ford it was claimed that exposure caused a rare form of brain cancer to manifest in one worker that eventually resulted in death. In each case, there was no scientific proof that RF/MW radiation had induced cancer in the company employees. There was also a report that M fields induced cancer in an individual that worked at the U.S. Embassy in Moscow. Again, there was no scientific evidence that supported the claim. 8. Recently, the Observer-Dispatch, a local newspaper published in Utica, New York, reported that a major study has just been completed in Sweden. The study concluded that children who live near high power lines have a greater risk of developing leukemia than children who live farther away from the power lines. The study involved 500,000 people and provided some evidence to link the electromagnetic fields produced by low-frequency power lines to cancer. The researchers, however, cautioned against drawing firm conclusions as a result of the research. 33.2. Effect on chromosomes. It has been observed that disturbances in chromosomic activity can cause cancerous aberrations to occur in the human body. In 1974, a paper published by K. Chen, A. Samuel, and R. Hooping-Arner, reference found in 8, reported that chromosomal abnormalities can be linked to chronic myeloid leukemia. Serious genetic mutations can also result from such abnormalities that can lead to malignancies in the tissue. 8. In 1976, A. A. Kapustin, M. I. Rudnaya, G. I. Leonskaya, and G. I. Nobikva, reference found in 17, reported alterations in the chromosomes of bone marrow cells in laboratory animals that were exposed to RW/MW radiation. They exposed inbred albino rats to a 2500 MHz F/MW source at incident power density levels of 50 and 500 UW/cm2. Irradiation lasted for 7 hours/day for 10 days. Upon examination of the animals, they 5. Observed chromosomal anomalies that appeared in forms described as polyploidy, aneuploidy, chromatic deletion, acentric fragments, and chromatic gaps. 17. The NIOSH Technical Report 8 summarizes the findings of several researchers. Chromosomal and mitotic anomalies have been observed in a variety of animal and human cells for varying exposures to RF/MW radiation. Pulsed and CW radiation ranging in frequency from 15 to 2950 MHz and power densities from 7 to 200 MW/cm2 have caused abnormalities to occur in chromosomes. The reported effects include linear shortening of the chromosomes, irregularities in the chromosomal envelope, abnormal bridges and stickiness, translocations, chromosomal breaks and gaps, chromatid breaks, acentric chromosomes, dicentric chromosomes, deletions, fragmentation, and ring chromosomes. 8. 3 mutagenic effects. Reported evidence indicates that biological interaction with M fields can cause the formation of mutagens in cells. In 1974, 3 Soviet researchers, Danilenko, Myrutenko, and K. Iodrenko, reference found in 8, published results showing a mutagenic effect of RF/MW radiation. Mutagens were observed to form in cells that were irradiated by a pulsed RF/MW source operating at 37 GHz and 1 MW/cm2 power intensity. They concluded that irradiation of tissue by pulsed RF/MW sources causes cell membranes to become more permeable to destructive chemical mutagens. 8. Results published in 1963 by G. H. Mickey, reference found in 8, showed hereditary changes to occur in Drosophila germ cells that were exposed to pulsed modulated RF/MW radiation for carrier frequencies between 5 to 40 MHz. 8. Evidence of RF/MW induced teratogenesis in animals has also been reported by researchers. The effect of exposure to CW radiation was observed by Rugg and McManaway in 1976, reference found in 8. They found gross congenital abnormalities in rodent fetuses that were irradiated by a 2450 MHz RF/MW source at an incident power intensity of 107.4 MW/G8. 4 Lymphoblastoid transformations. Lymphoblastoid transformations refer to changes in the physical nature of lymphoblasts. Mature lymphoblast cells, i.e. lymphocytes, participate in the immune system of the body. 18. Lymphoblastoid transformations induced by RF/MW radiation appear to be similar to transformations present in disorders contributing to abnormal growth in lymphoid tissues and in certain types of leukemia. RF/MW radiation-induced transformations, however, do not appear to be malignant and are not likely to spread among healthy cells. 8. W. Stodlink-Baranska reported, reference found in 8, lymphoblastoid transformations to occur when human lymphocyte cells were exposed to a 2950 MHz pulsed RF/MW source at power density levels of 7 and 20 MW/cm2. In 1975, Pechersky also reported, reference found in 8, observing lymphoblastoid transformations after irradiation of purified human lymphocyte suspensions by an RF/MW source radiating at 2950 MHz for variable power density levels. In addition, Chersky reported acute transformations occurring in adult mice and rabbits that were irradiated by a pulsed RF/MW source radiating at 2950 MHz and at low power density levels of 0.5 and 5 MW/cm2 respectively. 8. 6. Oncogenic effects have been linked to imbalances in the regulatory mechanisms of the body. A 1974 report published by E. Klimkovitcheva, reference found in 8, claimed that persons exposed to RF/MW radiation experience biochemical reactions. The report indicated alterations in fasting blood sugar levels, a decrease in the ability to dispose of normal metabolic waste, and depressed serum levels of pyruvate and lactate. These biochemical reactions point to the possibility of regulatory malfunctions occurring in the body. It has been suggested that certain regulatory imbalances may promote the growth of tumors. A change in hormonal levels has been observed to cause oncogenic effects in tissues that require hormonal balances to function properly. The presence of hormones in other tissue areas may affect the development of existing tumors in those areas. 8. Cardiovascular effects. Most of the cardiovascular effects of RF/MW radiation have been reported by researchers in the Soviet Union and Eastern Europe. Soviet investigators claim that exposure to low levels of RF/MW radiation that are not sufficient to induce hyperthermia can cause aberrations in the cardiovascular system of the body. 7. One experiment performed on rabbits indicates that several types of cardiovascular dysfunctions could be possible. An RF/MW source radiating at 2375 MHz was used to irradiate rabbits for a test period of 60 days under varying field intensities. For field strengths ranging from 3 to 6 V/m, researchers noted a sharp increase in the heart rate of the animals. This effect was observed to subside with time. Exposure to field strengths of 0.5–1.0 V/m caused the heart rate to become slower than normal. No effect was reported for rabbits that were exposed to M field intensities below 0.2 V/m. 17. Other effects that have been observed by Soviet researchers are alterations in EKG and low blood pressure. 7, 17. The NIOSH Technical Report 8 references a Soviet study published in 1974 by M.N. Sadsikova that suggests some connection between RF/MW radiation exposure and the potential for cardiovascular disturbances in humans. Researchers examined 100 patients suffering from radiation sickness. It was found that 71 of the patients had some type of cardiovascular problem. Most of these patients had been exposed to RF/MW radiation for periods ranging from 5 to 15 years. A smaller group of patients exposed for shorter time periods also experienced cardiovascular irregularities. The study concluded that there is a probable link between exposure to RF/MW radiation and cardiovascular disease. 8. The North Karelia project. In response to earlier Soviet reports, the World Health Organization, WHO, decided to conduct a comprehensive study on the biological effects of exposure to RF/MW radiation. In 1976, Zarid published the results of the study, reference found in 8. The WHO investigation focused on the population of North Karelia, a remote area of Finland that borders the Soviet Union. This region was selected because of its close proximity to a then Soviet early warning radar station. North Karelia is geographically located in the path of intercontinental ballistic missiles that would originate from the Midwest United States. To 7. Detect these missiles, the Soviets constructed a number of high-power tropospheric scattering radar units adjacent to nearby Lake Ladoga. The operation of these units exposes the residents of North Karelia to large doses of ground and scatter radiation. The WHO found evidence linking exposure of RF/MW radiation to cardiovascular disease and cancer. The North Karelian population suffered from an unusually high number of heart attacks and cases of cancer. In addition, it was found that the affliction rate of these diseases was much higher among residents living closest to the radar site. 8. Hematologic effects. There is evidence that RF/MW radiation can affect the blood and blood-forming systems of animals and humans. Experiments conducted in the Soviet Union have indicated changes in blood cell levels and alterations in the biological activities of hematologic elements. Other investigators have reported similar effects 7, 8, 17. The results of an experiment reported in 1979 by V. M. Stiemeyer showed a decrease in the biological activity of butyryl cholinesterase in rats that were exposed to pulsed RF/MW radiation, reference found in 17. The experiment subjected 15 rats to a 3000 mNz pulsed RF/MW source with an incident power density of 10 MW/cm2. The rats were irradiated for I/hour/day over several days. After 42 days, there was a loss of biological activity of the butyryl cholinesterase enzyme caused by a decrease in the concentration of the enzyme in the bloodstream of the rats. 17. Cholinesterase is a catalyst in the hydrolysis of acetylcholine into choline and an anion. Choline is a useful enzyme that prevents the deposition of fat in the liver. 181. In another experiment, 20 male rats were exposed to a 2376 MHz pulsed RF/MW source with an incident power density of 24.4 MW/cm2. Each rat was exposed for 4 hours/day, 5 days/week for 7 weeks. Blood samples were taken periodically and examined for anomalies. After repeated exposures, it was discovered that the number of lymphocytes and leukocytes, white blood cells, in the bloodstream of the rats was lower than normal. The biological activity of alkaline phosphatase in neutrophil leukocytes was also found to increase when the rats were irradiated. 17. The results of several other experiments are summarized in the NIOSH Technical Report 8. Re/MW radiation has been observed to cause an increase in the amount of exudate in bone marrow, the transient disappearance of fat cells from bone marrow, destruction and loss of essential bone marrow cells, underdeveloped marrow, a decrease in the number of red blood cells, and an imbalance in the number of lymphocytes in the bloodstream. 8. Effect to the central nervous system. There is documented evidence that exposure to RF/MW radiation can cause a disturbance in the central nervous system, CNS, of living organisms. 3, 8, 11, 17. Soviet investigators claim that exposure to low-level radiation can induce serious CNS dysfunctions. Experiments conducted in the Soviet Union and Eastern Europe have exposed live subjects to radiation levels that are near or below the recommended safe levels prescribed by the ANSI standard and the U.S. Air Force AFOSH standard. 17. 8. Pathological repair. Soviet investigators claim that the central nervous system, CNS, is highly sensitive to RP/MW radiation. 3, 8, 11, 17. The NIOSH Technical Report 81 summarized the results of a pathological study published by A. Letavet and Z. V. Gordon in 1960. The reported that several CNS-related disorders were discovered among 525 workers exposed to RF/MW radiation. The symptoms were listed as hypotension, slower than normal heart rates, an increase in the histamine content of the blood, an increase in the activity of the thyroid gland, disruption of the endocrine hormonal process, alterations in the sensitivity to smell, headaches, irritability, and increased fatigue. Other researchers have acknowledged similar biological responses. 8. Soviet Union Erpermenmal results. Several experiments have been performed in the Soviet Union and Eastern Europe that demonstrate a variety of biological effects that can occur in living organisms. Observations of laboratory animals subjected to low-power EM fields showed alterations in the electrical activity of the cerebral cortex and disruptions in the activity of neurons. 17. L.K. Yershova and U. D. Dumansky, reference found in 17, exposed rabbits and white male rats to a continuous wave 2.50 GHz RF/MW source. The animals were irradiated for 8 hours/day over a period of 3 to 4 months at power density levels of 1, 5, and 10 UW/Cr2. It was observed that rabbits exposed to the 5 and 10 UW/cm2 power density levels suffered alterations in the electrical activity of the cerebral cortex and disturb CES to the conditioned reflex response. They concluded that exposure to RF/MW radiation caused perturbations in the higher functioning centers of the CNS in the laboratory animals. 17. An experiment conducted by V.R. Fadelberg and G.M.P. Ravalov demonstrated the biological effects of RF/MW radiation on the activity of neurons, reference found in 17. They subjected chinchilla rabbits to a 460 MHz RF/MW source at incident power densities of 2 and 5 MW/cm2. Only the heads of the rabbits were irradiated and exposures lasted for 10 minutes. Exposure at the 2 MW/cm2 power density level caused neuronal activity to increase and evoked an electroencephalogram, EEG, activation reaction. Neuronal activity was observed to decrease at the higher power density level. These results indicated that RF/MW radiation can cause neurophysiological alterations in animals. These biological responses may be dependent on the intensity of the radiation. 17. 3. Behavioral effects. Exposure to RF/MW radiation has been observed to cause a disruption in the behavior of animals. Experiments conducted on rats and non-human primates indicates that conditioned responses can be altered as a result of irradiation. Researchers indicate that behavior may be the most sensitive biological component to RF/MW radiation. 1, 7, 9, 29. Dr. Justizen and N.W. King, reference found in 7, reported experimental results that demonstrated a degenerative behavioral effect in laboratory animals that were exposed to RF/MW radiation. The results were published in 1970. They exposed rats to a 2450 MHz multimodal resonating cavity system. Exposure was periodic with irradiation times lasting for 5 minutes and recurring every 5 minutes. This cycle is sustained for 60 minutes. The 9. Experiment tested the effect of irradiation at whole body energy absorption rates of 3.0, 6.2, and 9.2 W/kg. It was observed that for a SAR of 6.2 W/kg the behavioral performance of the rats degraded significantly and activity usually terminated at the end of the 60-minute exposure period. 7. In 1977, James Lynn, Arthur Guy, and Lynn Caldwell 29 reported experimental results that showed alterations in the behavioral response of rats that were exposed to RF/MW radiation. White female rats were trained to execute a head-raising movement in return for a food pellet. The total number of such movements was counted during each exposure session in order to quantify the effect of irradiation. The animals were exposed to a 918 mZ RF/MW source at power density levels of 10, 20, and 40 MW/cm2. Clinical observation showed that baseline responses remained unchanged for irradiation at the lower power density levels of 10 and 20 MW/cm2. At 40 MW/cmn, however, behavioral responses decreased rapidly after 5 minutes of continuous exposure. After about 15 minutes of exposure, behavioral activity terminated. It was determined that the peak energy absorption at 40 MW/cm2 was about 32 W/kg and the average absorption was 8.4 W/kg over the whole body surface. 29. 4. Synergistic effect of drugs RF/MW radiation in 1979, 1. R. Thomas et al. Reported that psychoactive drugs and RF/MW radiation may have a synergetic effect on living organisms. References for Thomas can be found in 1d. Experiments were conducted on laboratory animals. Male albino rats were administered dextroamphetamine and irradiated with a pulsed 2450 MHz RF/MW source at 1 W/cm. Power intensity for periods of 30 minutes. It was found that the number of clinical responses observed per minute in the rats diminished more rapidly under the stimulus of both agents than in the control condition where just the drug was administered. This indicates that the effects of RF/MW radiation may be enhanced by certain drugs. 1. The analeptic effect in animals. Pulsed RF/MW radiation was reported to have an analeptic effect in laboratory animals. Experimental results presented by R.D. McAfee in 1971 showed that anesthetized animals could be awakened by irradiation from a pulsed 10 GHz RF/MW source. The energy incident on the test animals was estimated to have a power density of between 20 to 40 MW/cm2. Experiments conducted on rats showed that these animals were aroused from states of deep sleep by irradiation. It was observed that the blood pressure of a rat decreased simultaneously with the arousal response and that laryngeal spasms would occur when the rat was awakened. McAfee reported that the laryngeal spasms would obstruct the airway, causing convulsions, asphyxiation, and eventually death. Other experiments performed on rabbits, cats, and dogs showed that these animals could also be awakened by irradiation. The larger animal, however, did not asphyxiate themselves. The blood pressure of the dogs and cats was observed to rise as they were awakened. In all cases, the arousal response was stimulated only when the head of the animal was irradiated. The body temperature of the test animals was not observed to rise as a result of irradiation. This indicates that the analeptic effect of RF/MW